All right, so welcome back, everybody. Please turn your webcam on if you could, if you don't have it on already. Um, so let's talk a little bit about the tools that we're going to be using this semester. So we spent the first hour motivating why we have this class. We've spent the second hour talking about what we're going to learn and do in this class. Not in super detail, but at least some of the major topics we're going to be covering in this class. Okay, so let's get started. So we're going to be writing code this semester. So let's start meeting some of our tools. Some of them you will be familiar with already. All right. My goal is in this class, I'm hoping that all the tools we can use can be free at least, so we don't have to pay any money to use them because even though we're going to make a distributed system with many servers and things, I don't want you to have to spend money on that. And as much as possible, we're going to favor open source tools if they're available. All right. And the other thing is you're going to find that this semester we are going to try to do everything in code. We're not going to use any high level wizards or some very fancy development environment. We're going to try to do everything at a very low level, at a very code based level, so that you have a strong understanding and strong mastery of what we are learning. All right. So let's see what we're going to be using this semester. To begin with, let's see. To begin with, your operating system. All right. I know a lot of you are probably using Windows. Some of you may be using Macs. This semester, all our code, all our development will be done on a Unix-based systems. So if can I just see a rise of hands? How many of you are already already use Linux on your as your main operating system? Not Windows on Linux, not Linux on Windows, but just pure Linux. How many of you have a pure Linux machine or pure Unix machine? Anybody? All right. Um, and how many? Okay, so how many of you use a Windows? So can I see a see some hands? How many of you use Windows? All right, so you're not sleeping. You're really using Windows, most of you. All right, great. All right. Any more people? Yes, a few more people. Great. So we have a lot of Windows users. So you can lower your hands now. All right. And how many of you are using Mac, are on a Apple system? Wow, almost as many as are using Windows. So our class is probably slightly majority Windows, but almost half Apple, half Windows, which is fine. So let me just tell you like what you need to be using. So if you are using Windows, then you should we will be doing our development this semester on Unix-based systems. So if you're using Windows, you need to install Windows Subsystem for Linux, or WSL, which allows you to like basically use Linux in your Windows command prompt, okay? And I'll give you some instructions if you haven't done it already on how to use WSL. Out of curiosity, how many of you already have Windows Subsystem for Linux installed on Windows? Anybody? All right, all right, all right. So a lot of you who are using Windows, or maybe half of you who were using Windows, already are already using WSL. That's fantastic. Okay, thank you. Um, but for the rest of you, I'll give you some instructions on how to install it so that we're going to do all our programming and development in a Unix environment through Windows. All right. Now, it's not a WSL is not a virtual machine. It's actually sharing a Linux kernel with Windows. All right. For those of you on Mac OS, on using an Apple, you don't have to change anything because Mac OS is actually a Unix-based operating system. But I do have to ask you one important favor. Sometime in the coming months, maybe end of this month, maybe tomorrow, or sometime this month or next month, Apple will release a new operating system. I think it's macOS Monterey or something like that. There'll be a new operating system. Please don't install it for at least some weeks or maybe 1 month. Okay. The reason I say that is because every time they updated their operating system, it breaks a lot of Unix libraries that we need for our development. So, I mean, you can, but I'm just saying it may break things. So I will prefer if you can give me a week or two or three to update my operating system first. And then if everything goes well, me and my TA might do that, and then we'll share with you if we have any problems, okay? The other thing is usually the first release of the Mac operating system, I mean, it'll have bugs in it, so it's better to wait for a month and get the next minor release. So wait for the point 0.1 release to come out before upgrading is my advice to you. All right, because the first release can have a few bugs in it as well. So if you're using Macs, please just hold off for a month or so. Okay, so that's what we need in terms of operating systems. All right. Let me quickly address a question that's on the discussion channel. So Sunny asks that, hey, I've filled in the survey but not been invited to Slack or Canvas. Uh, if you are registered for the class and you have done the survey, then we will send you an invitation later today. Okay. If you have not registered, please send me an email or let me know if you have any if there's any problems. Okay. All right, let's move down. So we're going to be using the Ruby programming language this semester, and there's a whole lot of options about operating systems. So let's talk about programming languages for a moment. All right, this is a chart ranking, and I hate rankings of programming languages, but this is one way of ranking programming languages. So this is a graph of different programming languages. And you can see that on the x-axis is their popularity on GitHub, like how many projects are use this language on GitHub. And on the y-axis is how many questions on GitHub, on Stack Overflow are tagged with this language. So you kind of see how often this language is used on GitHub versus how often it is discussed on Stack Overflow. All right. No surprise, the most popular language, or maybe it's a bit of a surprise, the most popular language probably in the world right now is JavaScript. All right. It kind of took over from Python's position in the last couple of years. Python is probably, yeah, the second most popular language there is right now, mainly driven by data science. And Java is still, I mean, I learned Java when I was in college. That was a long time ago. So Java has been popular for decades now. It's not going anywhere, okay? PHP still super useful. In fact, I will argue that this graph is wrong. PHP is probably easily the most commonly used language in the world because there is millions of WordPress websites out there, and they're all using PHP. So PHP is probably, this graph is probably wrong because it's only looking at GitHub and Stack Overflow. If you look at actual production servers out there, PHP, like, it's way out of this chart. It's like somewhere on the other side of my room. Okay, it's probably the most popular language. Ruby is not the most popular language. It's fairly common in web applications, but it's not very popular for anything else. All right. So why do we have so many languages? Like, look at all these languages that are out here. My God, this is crazy. All right. Um, why do we have so many languages? Anybody? Any thoughts, any suggestions? Why do we have so many languages? Why do we need so many languages? Why don't we just have one language and just everyone just use that one language? Any thoughts? I'd love to hear some comments about why we need so many languages. If PHP is so popular, why don't we just keep advancing PHP and, you know, make everyone use it, or Java, you know? Why do we need Python and JavaScript and Ruby and TypeScript and Objective-C? Did I miss a? Oh, is there a hand up right now? Sorry, did somebody raise their? If you raised your hand, please go ahead and unmute yourself and let me know. Otherwise, feel free to, or else I'd like to hear some opinion. Why do you think there are so many languages? Anybody? Billy, go ahead. Okay, excellent. So thank you, Billy. Thank you for that answer. Yeah, so different languages may focus on different things, but and a lot of you are saying the same thing for different systems, different purposes, for different usage. Like for quick testing, we may want to use Python. For high efficiency, we may use C or C++. I won't argue against that. Some languages are efficient, some are easier to learn. Okay, so a lot of you are telling me that they're for different purposes, but let me push back against this notion. Um, I mean, there's nothing you can do in Python you can't do in other languages, is there? Like, I mean, I understand Python has some libraries that may not be available in other languages, sure. But there's nothing in the language of Python that makes it so super different from Java or Ruby or JavaScript. I mean, they all look kind of similar. And I mean, if you write a for loop in Java, it's the same for loop in Python, it's the same for loop in JavaScript. Like, what's different about them? Right? So I love this answer that Billy gave me. That a lot of you are typing here. Shichu wrote this, and others are saying this for different purposes. But to me, they're all general purpose programming languages. They all look really similar to me. So why do we need all of these, right? I mean, Python doesn't look so different from Java. Okay, you don't have curly braces, but so what? Like they're all just general purpose programming languages. Why do we need so many of them? Right? It's a tough question, and I love this first answer that you're all giving me, and I agree with it. There's something about the usage of it. Okay. Um, One answer that I really like, and this is from Larry Wall. He's the person who created the Perl language, and he's got a lot of great philosophies about programming. And he says that programming languages are not different in what they make possible; they're different in what they make easy. So different programming languages make different things easier to do. They can all do the same things. It's not like you can do some things in Python you cannot do in Java. Absolutely not. you know. So it's not about what they make possible. It's just that different languages make different things easy to do. All right. So if I go back to this figure here, um, languages like Python and JavaScript, Ruby, these are dynamic languages. They're really easy to learn, and they're really easy to start developing systems right away. You don't need a lot of overhead to start developing your system. Arguably, with C++ and Java, you need to do a little bit more upfront work to do certain things. As you'll see later this semester, for example, in Ruby, a lot of object-oriented programming, a lot of object-oriented design patterns are built into the language. You don't have to like write your code in a specific pattern. It's already part of the language. So some languages like Python and Ruby have made a lot of efforts to make some design patterns, some common patterns of description common and easy to develop in the language. You don't have to write a lot of extra boilerplate code, which you would have to write in C++ or Java. Okay, so they're making it easier to write high-level applications in Python and Ruby. All right. Languages like C++, they give you a lot of control about system level things, about how you're using memory and how you're using the processor. They give you a lot of flexibility in how to kind of specify how to use your system resources. To some degree, you can do those in Ruby, Python, Java, and all these languages to some degree. But in those languages, it's much more direct to access system level resources. Okay. Some other languages, like let's take Erlang over here. Erlang was written long time ago, maybe in the 80s or 70s. And it's how many of you have heard of Erlang, by the way? A little raise of hands. You can do the hands button. How many of you have heard of Erlang before? Not many people. Nobody. Erlang is a language that was written decades ago, and what it makes very easy is to write highly distributed applications, like applications that are distributed across different processes and even different computers, so that you can write applications that are highly distributed and fault tolerant. Built into the language is some constructs that allow you to catch machines crashing, processes crashing, and recover very quickly. So it's kind of like a self-healing language. When things crash, it can recover very quickly. So it was written for that kind of for that purpose, to make it easy to distribute and easy to survive crashes. Where it is used is for in environments where you have to create a system that's highly distributed and it cannot have any crashes. An example of that is mobile cell phones. So cell phone towers, a lot of the networks a lot of the networks for cell phone towers are written using the Erlang language for that reason. Recently, Erlang has been really popular also for instant messaging applications like WhatsApp uses Erlang in the back end because you need to have hundreds of millions or billions of people talking to each other at the same time, and they don't want to have any disruption. So they use this language that's custom built for for fault tolerance and very high distribution. All right. Um, so different languages, I mean, they all, and by the way, you can write fault-tolerant distributed applications in Python. You can do it. It's just a real pain in the ass to do. It's just very difficult to do it in Python because that language is not making that easy to do. So languages are not different because they allow you to do different things. They're different because they each focus on what they want to make easy for you. All right. And by the way, this is a histogram of all the languages that you told me that you use. So of all the students who did the survey, at least until a couple of days ago, so I don't have the latest responses, but I have most of you. Um, so you can see that Python is the most popular language. It's been the most popular language for students coming into this class for probably 3 or 4 years running. JavaScript is picking up at a very scary pace. Maybe 4 years ago, JavaScript would be in the middle of this graph somewhere. It was not very popular. But JavaScript, I'm guessing in the next 1 or 2 years, JavaScript will overtake Python and become the most popular language, at least for young people, at least. Okay. C++ and Java are still popular because schools teach it, at least in computer science departments. All right. And these other languages, for the most part, you picked it up in some classes or in some internships or some jobs and things like that. Okay. So a really nice diversity of people using languages. However, in this class, I am not going to allow you to pick whatever language you want for a couple of reasons. One big reason is I want to be able to read your code and grade you on your code. So I have to be able to understand the language you're writing. So for that reason, I'm picking one language. But there's another thing. I'm picking a particular language, which is Ruby, and I'm picking it for a reason. Let me talk about some of the other languages to begin with. So for those of you who write like C++, Python, Java, Go, a lot of these languages have the same ancestry, meaning they all come from the same place. Languages like Python and Java and Go are heavily influenced by C++, which is heavily influenced by other languages, maybe all the way back to the 1960s with Algol. So, I mean, here's an example. Here's a for loop that I've written that in Algol, and this is not a typo. In Algol, you end a do block with the words do backwards. So it's OD, okay? So that was in the 1960s. But this is what a for loop looked like in the 1960s. This is what a for loop looked like in the 1970s and 1980s. This is a for loop in the 1990s. This is a for loop. It looks a little bit different now, but this is a for loop, let's say in the 2000s. This is a for loop in 2010, all right? To a certain degree, hold on a second, something is crashing for me. What is it? PowerPoint? No problem, I'm not using it. All right, so for a certain part, one of the criticisms I have of a lot of programming languages is they haven't changed a whole lot. You're still writing the same code that, the professor who taught your professor learned in college in the 1960s. Okay, so I want to kind of shake up your understanding of programming a little bit by making you learn a different programming language that will do things in a very different way. All right. By the way, do you know what this code is doing? Can anybody just look at this code and tell me right away what this code is doing? Go ahead, tell me in the chat window. I'll show you the C++, Java, Python. That should be quite good enough. Anybody want to tell me what this code is doing? Come on, shouldn't be so hard. All right, we're getting some answers here. Yes. Yeah, okay, thanks, Billy. Yeah, exactly. It's printing out even numbers. In particular, it's printing out even numbers between 1 and 10. All right. Cool. You can see that. And how do you know that? Because, well, you can see the number 1 and the number 10 somewhere. And you know it's even numbers because it's doing a modulo 2, which basically tells you what's the remainder from dividing by 2 and checking if the remainder is 0. All right. Um, Interesting. And pretty much in all the languages, now I might be wrong, maybe in Python there's a different way to write it, but in all the languages, this is pretty much the standard way to write this code. What are the even numbers among the first 10 numbers in the number system? In Ruby, you wouldn't write it like this. This is how you should write it in Ruby. Um, and this looks a really difference, right? So we're saying 10 times, take the number I and print to screen if it is an even number. Now that looks really different from what the other languages are doing, all right? And I want to take the opportunity to do a couple of things this semester, which is to shake up a little bit of what you know about how to write code. Now in Ruby, this looks totally different than maybe what you have learned or what you would do in other languages. But I will argue with you that in most of those other languages today in 2010, they would encourage you not to write the code like this. They might encourage you to write it a bit more like what you're seeing in Ruby. All right. The reason I've shown it to you this way in these other languages is a lot of the times programmers are writing code as if it's the 1960s still. Like we're still writing code like from half a century ago. But in a lot of these languages, the community that is around these languages has changed the style of coding, but a lot of students are not familiar with it. So I want to take the opportunity to shake up what you know about how to write code and to encourage you to go back to your favorite language. It might be Java or Go or Python or C++, and see what is the community encouraging you to write today. All right. And one good way of doing that is to kind of see how a language that's completely different does it. Ruby looks a lot different from a lot of these languages because Ruby does not, I mean, Ruby borrows a lot from Java, certainly, and it borrows a lot from Python. But Ruby fundamentally borrows a lot from, mainly from Smalltalk, which was the first and probably to this day the most pure object-oriented programming language ever. And it borrows a lot from Perl, okay, and from Python as well. So Ruby will look like a combination of Python, Smalltalk, and Perl for the most part. And I want you to kind of understand why this looks like such, why it looks so different. Like, what were they thinking to make it look so different? And once you've done that, I want you to, and over the semester, I'll ask you several times to go back to your favorite language and to rediscover how that language should be written or could be written today. All right. So my purpose in using Ruby is not to make you all Ruby programmers. Very few of you will leave this class and go out to write Ruby. Maybe just a few of you. But when you leave this class and you return to your favorite language, you will suddenly realize that you maybe were not writing your favorite language correctly the whole time. I mean, you were writing it correctly, but not the way that it is written today in modern programming communities. All right. So I'm going to use the Ruby language as a kind of a gateway to introduce you to how other languages should be written. Also, a lot of modern languages coming up today, like Elixir, Swift, Julia, borrow a lot of ideas from Ruby. Ruby's become a very influential language in terms of its style. So in the next 10, 20 years, the new languages that are going to become popular are going to look probably more like Ruby than like Java. All right. So it's a good chance for you to kind of get up to date with a lot of modern ways of expressing yourself in code. All right. I'll definitely tell you today that in 2020, the Java community discourages you from writing code like this, probably. All right. And I'll talk about some of the reasons why they discourage you from writing code like that. So we'll talk about a lot of this, and I'll use the Ruby programming language as a way to open up your eyes to other languages and other ways of expressing yourself. So we're going to use the Ruby programming language. Okay, cool. Um, Techniques. So I asked you also in the class, what kind of programming techniques do you already know? And I gave some very high level techniques. The most popular techniques, of course, are HTML, basic object-oriented programming. A lot of you know how to use Git and version control, which is great, command line, and database design. Actually, I will say these things are prerequisites for this class. It's okay if you are not familiar with Git. I will try to introduce it, but if you know Git, you'll have a big advantage because we'll use it very heavily this class. But HTML, basic object-oriented programming language, and database design are prerequisites. You should know how to do those for this class. I noticed that maybe 2/3 of you are only comfortable with database design. I hope when you form teams, there's at least one person on each team who is comfortable with database design, okay? Interestingly, Git was something that was like, let's say 6 years ago or 5 years ago, very few people in the class would know Git. I'm happy to say every year it's becoming more and more familiar to students, even students coming into the master's program for the first time, okay? These are possibly some new things. I noticed not many of you, maybe less than, maybe only 1/3 of you or less than a third of you are comfortable with testing. We're going to spend a lot of this semester talking about testing, so you're in the right class because we're going to learn a lot about testing. Advanced object-oriented practices like design patterns and other things. We're going to spend a lot of time talking about this semester, so it's okay if you don't know that. That's what we're going to spend time talking about this semester. Things like how to deploy to cloud and containerization. It's becoming, I'm finding every year these two things are becoming more and more well understood. I'm expecting that maybe in 5 years' time at most, containerization will be as well understood by students as Git is today. Okay, that's my expectation. So we'll talk about how to use Docker and things like that in this class, maybe towards the end of the semester. All right. So I do have to warn you, if you are not comfortable with like making an application by yourself using basic object-oriented programming, version control, database, and HTML, this class will be a little difficult because I'll go through those super fast. This is not a class to learn how to make an application. This is a class for people who already know how to make an application and to take it to the next level, to learn how to make highly scalable and well architectured and cleanly written applications. So this is not a good introduction to basic application development. If you really wanted to learn how to write an application, I can suggest other classes that will be a much better and slower introduction and a more patient introduction to application development. This class assumes you know how to write an application. Now we're going to show you how to write a very advanced application. All right. So please keep that in mind. And if you feel you're too much of a beginner, I suggest you drop the class and do one of two things. Either take another class, which I can suggest to you if you email me about it, about how to write, applications, or else I can point out to you some online courses that will teach you those things, and you can prepare yourself for next year, and you can take SOA maybe in the next year. Okay. All right. Cool. Moving on. So these are some of the tools we'll be learning or using this semester. So basic like Unix, Ruby, GitHub and Git, Slack we'll be using for communication. These are some of the frameworks in Ruby we'll be using for databases and application development and testing. These are some of the cloud services we'll be using, GitHub and Heroku. These are some of the data-related services we'll be using: SQLite, Postgres, and Redis. This is actually, and we'll learn how to use Amazon SQS for message queues to create distributed applications so they can communicate with each other. And towards the end of the semester, we'll learn a little bit about how to use Docker to create containerized applications. All right. Any questions on the tools that we'll be using this semester? Right. Any questions? I'll take a quick water break to wait and see if anybody has got any questions. Maybe just 10 seconds. Anybody wondering any details about Ruby or Unix or anything in particular we're going to be using? No? All right. I'll keep, so let me just describe a couple of other things then, all right? Seems everyone is comfortable. So let's go back for a second to our class, to Canvas, our class discussion board, all right? So once again, if you've not been invited, I will send you an invitation if you've done the survey and you're registered as well. Well, if you do the survey, I'll send you an invitation. So a few things. So you'll see that on Canvas, there's some class resources. I've already mentioned we will always use the same link that we're using today for Google Meet. So you can save. So this link is on the Canvas website. There is a YouTube channel that I'm live streaming today, but I will ask on Slack later this week if we should still keep using YouTube. Otherwise, I'll just use recordings on Google Meet if that's good enough for anybody. But if someone says that no, Google Meet is not like the live interaction is not very good, then I will consider keeping YouTube still going. Okay. I mentioned some of the class materials. So let me just dig into some of them. I showed you the syllabus earlier, but you can read it in your own time. I mentioned that we have a Facebook group. All right. And the Facebook group is called Web Service Development at NTHU. Let me make this window a little bit bigger. All right. These are some students from, like, I don't know, several years ago who did this class. All right. And what we do on this Facebook group is we share stories about software development and web services in particular. We have some funny things, some intellectual things, and you'll see a lot of students on this board. A lot of the people talking on this board are former students of the class who are now in industry. So it's a great way to get to know people who are in industry as well. And sometimes they will post some job listings and things like that. Okay, so for example, here's a job listing from somebody who found out about this platform. So they said, hey, we're looking for some employees. All right. Um, and yeah, so you'll see a lot of the posts are also from previous students and things like that and their thoughts. So it's a great place to interact not only with our students, but also with former students who are now working in this industry. Once in a while, I invite previous people like this student from France, Melvin. He kind of audited this class several years ago. He now works for Elasticsearch, so we invited him to do a 30-minute talk. And when we have talks like this from industry people who've taken this class, I'll definitely invite everyone in this class as well. Okay, so it's a great place to kind of share some of the stories we have about software development. So I encourage you to come and join this group. Okay, all right, cool. Let's see what else. Let's go back to Canvas. For this coming week, I've set up some assignments. I may have a reading assignment as well. I haven't decided yet. If I do, I'll let you know on Slack and I'll update this Canvas site as well. Let's take a look at some of them. The first link is about the survey, which you should have done by now. I think all of you have done this by now. The second link is a description of how to set up Unix and Ruby. All right. And it's a Word document. And on it, I've got some instructions if you're using Windows, how to set up WSL for Windows so that you have kind of a Unix platform on which you can do development this semester. I give you a second option of using a virtual machine, but I don't recommend that anymore. Okay. And once you have WSL installed, or if you're already using Mac OS and you're on a Unix system, some instructions on how to install Ruby. All right. A couple of things. Like many languages, Ruby will have many updates. So I don't know what's the popular, like right now, the latest version is 3.0. I don't know, 2 or something like that. So over the semester, you may have to, at some point in time, upgrade your Ruby. I think in December, a new version of Ruby will come out. So we will update our Rubies. So we want to be able to handle multiple versions of of the Ruby language. So we're going to install something called RBEnv, RBENV, which is a tool that allows you to have multiple versions of Ruby installed on your operating system. Okay, so I'm going to ask you to install RBENV and then use RBENV to install Ruby, the latest version of Ruby. All right. For those of you who use Python, You may be familiar with a similar tool called PyEnv for Python. And PyEnv is actually a port of RBENV. So that's where the idea of these ENV tools comes from. It actually comes from Ruby. All right. So you'll be installing Ruby RBENV to install multiple versions of Ruby, and you'll use that to install the version for this class. Okay. And it's not version 2.7.1. Let me find out what's the latest version. Latest Ruby version 3.0.2. Fantastic. So this is a Google document, so I can quickly change this to 3.0.2. Okay, great. So you'll be installing Ruby 3.0.2 on your system. All right. What else? So we're going to use two platforms in the first few weeks of this class. One's called Code Academy. Code Academy, I think a lot of you are familiar with it already. It's a tutorial website where you can learn new things. So in particular, I'm going to ask you to go to Code Academy to learn how to write code in Ruby, because I'm not going to teach it to you in class. It's going to be like part of your homework assignments, okay? So we're going to learn Ruby over the next 3 weeks. So for the first week, these are the lessons I'm going to ask you to do. So go to Code Academy, and you'll have to create a new account on Code Academy and do these lessons for this week. Next week, I'll have new lessons. By the way, once you've created your account on Code Academy, I'm going to ask you to, there's a link here called, this is an assignment here for 2 points, to let us know your Code Academy and GitHub usernames, okay? So this little mini assignment is to basically go set up a Code Academy account and a GitHub account if you don't have one, and tell us your Code Academy username and your GitHub username, all right? The TA and I will use your Code Academy username to make sure you're doing your Code Academy tutorials. So next week, we will look at Code Academy and look at your user profile to see which tutorials you've done, and we will give you your points for doing so you'll notice that setting up, you'll see that the Ruby tutorials is worth 10 points, and we will know if you've done the tutorial or not by looking at Code Academy, all right? So please set that up and let us know. And let me just click on this Code Academy tutorial once so you can see what it looks like. Okay, here we go. So here's the tutorial, and basically it's you'll be doing part of introduction. You'll be doing this introduction to Ruby and control for Ruby this week. Next week we'll focus on some of these, and there's a few more lessons which we'll do in the third week. All right. So this is how we're going to learn Ruby for this class. All right. If any of you are not comfortable with Unix, then I've provided an optional tutorial. I'm not grading it. It's just a website that I kind of modified. I kind of copied it from another instructor who made this website, and I've modified it. And it basically gives you some tutorials on how to use the Unix command line, all right? And for week 1, I suggest you, if you don't know how to use Unix, you do tutorial 1 and 2 of this Unix tutorial. All right, great. So that's the Canvas website. All right, and we will kind of give you some grades on Canvas. Notice that we're not going to use Canvas for any discussion. All our discussion will happen on Slack. So for week 1, where you're going to be learning some Ruby and setting up Unix, I'm going to suggest that you use this channel on our Slack workspace called 01 Ruby Unix for any questions that you have. All right. I will also share with you later, maybe this week, some notes that students from previous semesters have taken about difficulties they had in either setting up Unix or setting up Ruby. All right. And you're welcome, and it's a HackMD site, so I believe you're welcome to also go add your own notes and update. If you have any new troubleshooting that you discovered, you can kind of go do that. But if you run into any problems, you can look at that HackMD page, and you can also ask us on Slack and say, hey, I've got some problems. Now, I strongly suggest that you start working on these things and your tutorials as soon as possible. One thing you'll find about this class is you cannot do these assignments the night before. It just doesn't work. You probably should start the day after class or even the day of class and spend a couple of hours or 1 hour every day trying to like finish all these things. All right. From next week, I'll give you more tutorials and also some coding assignments. So the first few weeks of class, you will get some individual coding assignments to get you up to speed with programming in Ruby and using Git. And then maybe from week 4 or 5, or maybe, yeah, 4 or 5, we will start forming teams. And by week 5 or 6, you'll be working purely in teams. All right, cool. Let me just take a little pause and see if you have any questions about this class, whether you're suitable for it, whether about the tools we're using, about the motivation, about what the project will be about, or anything. Any thoughts or questions? Anybody? All right. So please check the Canvas website. Please make sure that you check Slack regularly, because after today, I may or may not send any more. I may not send any more emails after today. I just want to get off of emails. So all our discussion will be on Slack. You'll also notice on Slack that me or your fellow students will often post updates. I may give you a reading assignment that is not on Canvas yet. I may update that later today or tomorrow, maybe. So you need to check Slack regularly, every single day at least, okay? Maybe multiple times a day would be even better. Oftentimes you will find other students are telling you, hey, here's some problems I ran into and here's how I solved it. So check Slack, you'll get a lot of tips from your own classmates and from me and the TA about how to do it, okay? Having mentioned the TA, Tony, could I ask you to turn your microphone on and introduce yourself? Our TA for this class is Tony Lin. Could you just say a few words to introduce yourself? And that's it. Can you tell us what your undergraduate was? Tell us a little bit about your work experience. Cool. Thank you so much, Tony. So Tony is going to be our assistant, and you can find him on Slack as well. So you can talk to either of us on Slack. Okay. All right. Cool. So I hope you have a fair idea from today's lecture about whether you belong in this class or if this class is too much. If you feel the class might be too much for you or a challenge, I strongly encourage you to drop it and contact me, and I will suggest you some resources so that you can get stronger and come back and take it next year, okay? Because this class will move extremely fast. I'll try to be a little slow the first couple of weeks, but you'll see the class is going to be a very fast moving class. Also note that you will have programming as you'll have individual assignments the first few weeks. Once we start the group, your group has to produce a new feature every single week. So you cannot take a break from this class. You cannot say, "Oh, this week I'm just going to listen to the lecture. Maybe I'll do the assignment another time." There has not been a single group in the past 10 years of this class which has skipped 1 or 2 weeks and then caught up. Especially after you miss 2 weeks, you're never going to catch up. So you have to stay up to date with this class every single week, which means programming you'll have a programming assignment. Actually, there's a new feature for your application every single week, and you have to do it that week because catching up is almost impossible. So I regret to say that every semester there is probably 3 to 5 students who have to drop out by week 8 or 9 when they realize the load is too high and they can't keep up. And unfortunately, there's probably 2 to 3 students who fail the class every semester as well because they completely underestimated the workload of the class and thought that they could catch up later in the semester and then realized there's no catching up in this class. You just have to keep up to date every single week, okay? So, um, but the advantage will be for those of you who take the class, it'll really set you up not just as an entry-level developer. Students who've taken this class have mentioned to me and their colleagues that after they've taken this class and they go join a company, they almost feel like they know as much, if not more, than their senior developers or their tech leads. So a lot of students who come out of this class within 2 or 3 years, they go from being entry-level programmer to being tech lead or senior developer in their company. So it really boosts you into a new orbit as a software developer, and it puts you in a position to be a tech lead within a couple of years, within a few years, and to be like managing um, product teams within 5 years easily. All right. So that's kind of the purpose of this class is to kind of really take you to the next level of software development. All right, cool. Thank you all very much for attending today. I'm going to turn off the recording and I will hang out for about 5 minutes or so. Wait, hold on. There's a hand raised. Edgar, go on. Go ahead with your question. Oh, I didn't see that. Oh, yes, I see it now. Thank you. So each one asked this question. How many students can be on each team? Thank you, Edgar, for pointing that out to me. Um, the limit is there can be 2 or maximum 3 students to a team. All right. Why is that? Because, well, if you want to work individually, you can, but you have to give me a really good reason because otherwise I'm going to deny you. Okay. So, unless you have a very good reason to work individually, you have to work in a team. And you cannot just say, oh, I don't like teammates. Well, that's not a good reason. Okay. So it's got to be 2 to 3 students. Why not 4 or 5? Because I've never seen a team of 4 students actually have 4 working members. It's usually 2 or 3 working people and one person not doing anything. Even on a team, so a team of 3 is kind of ideal because what you'll find is that you can rotate, you can each, contribute something, and you can learn from each other. A team of 2 is also possible, but a team of 2 usually means that you both have to be working together every single week. Like literally nobody can take even a breather. Okay. So a team of 3 is more ideal and you can learn from each other and help each other and you can each have some different strengths. Okay. Now, having said that, let me just mention some things that are not acceptable. Um, you cannot be on a team and say, hey guys, I'm just going to do the HTML and CSS. I'm not going to do any coding. That's not acceptable. I'm expecting each team member to contribute in a significant way in the project, not just like, hey, I just do the interface stuff, not like that, okay? I expect each person to have contributed to multiple parts of the application in significant ways that shows me you really understand the main topics of the class. So you cannot just hide and say, hey, I'm just going to do some front end, or hey, I'm just going to do the database design and nothing else. No, you can't do that. Everyone needs to contribute a significant chunk to the different parts of the application. All right. So there's a big expectation. And do remember again, and I don't know why I mention this every year, and at the end of the year, some students are surprised to find out I check every file of code, I check every line of code, and I use a tool that tells me who wrote every line of code, and I read it to get a really strong understanding of who you are as a developer, what you've contributed, and what your understanding is. And so, but yet, even after warning you this, every semester, at the end of the semester, there's a student who fails and says, hey, I wrote a lot, who says, there's some excuses I don't accept. Like, for example, students tell me, hey, my computer broke down in the middle of the semester, and so you don't see many commits from me. And I say, that's too bad. That means all the credit goes to your teammates. I get excuses from students saying, I didn't write a lot of code, but I was helping my teammates with everything, and I was very valuable. Tough luck. I only look at the code, not at your aura of what a good person you are. Okay, show me the code. What are some other excuses I get? Um, I don't know, but I get a lot of weird excuses at the end of the semester. So just to let you know right now, you are graded on your code, your contribution to your project. So it is not surprising to have a team where one student did a lot of the work and they get an A or an A plus. Another student gets, I don't know, like a B and another student fails. It's very common because I only give credit to the students who've actually contributed something. All right. So please be aware of what you're stepping into. This is a serious software development class, not a management talking class. Okay. And I'll end the lecture by simply saying, why am I teaching a coding class in a management school? What a weird thing. The reason is because, as you saw, the problems we are trying to solve in this class, all right, the problems we're trying to solve in this class are um, are technical. They look like technical problems, but they're actually human problems. How to manage teams, how to manage multiple people, how to like manage how people are contributing things. All right. And fundamentally, I'm trying to avoid some human problems, some management problems, which is I'm trying to avoid, excuse me for jumping around, I'm trying to avoid, you know, a work environment where people are fighting fires, not learning new things, getting blamed, losing motivation, right? Um, Unsure of what their career. I'm trying to avoid all these things. And these are all human things. These are all management problems. Unfortunately, most people think the solutions are also management solutions. And I will argue the solutions are more technical in nature. They're about how do you write code? How do you express yourself? How do you manage your code base? How do you manage your teams? So we're going to learn a lot of technical solutions to a lot of very human problems. We're not trying to solve technical problems. We're trying to solve human problems. That's why it's in a management school, because management is all about managing humans. Okay, so this class is really at the intersection of computer sciences and management, where we learn to solve management problems using technical solutions. All right, so that's our class. Okay, having said that, I don't see any other comments, so I'm going to stop the recording. Welcome to our class. I will hang out for about 2 or 3 minutes or 5 minutes to see if any other questions are there. So let me stop the recording and also stop live streaming.